Okay guys, we're back with the Odin Project and command line basics, and we still have to work on pipes and filters, so we're going to go ahead and do that. I guess I gotta click on this again. Pipes and filters. Now that we know a few basic commands, we can finally look at the shell's most powerful feature. The ease with it lets us combine existing programs in new ways. We'll start with the directory, shell lesson data, exercise data, proteins, that contains 6 files describing simple organic molecules. The PDP extension indicates that these files are in protein data bank format, a simple text format that specifies the type and position of each atom in the molecule. So, I didn't realize I probably should have been doing some of the things from before, but let's see if we can go there. So we're in shell lesson data, exercise data, and we need to go cd dash so cd /home /britter /desktop shell lesson data exercise data proteins. And okay, so we have 6 files inside. Alright, so we're gonna run an example command, wc cubane.pdb. Okay. Okay. WC is word count command. It counts the number of lines, words, and characters in files from left to right. So there's 20 lines, 156 words, and 1158 characters. Let me scroll up a little bit. Alright, so if we run the command wc.pub, the star in the pub matches 0 or more characters, so the shell turns pub into a list of all PDB files in the current directory. So let's do wc star.pdb. Alright. And ours matches up. Note that wc.pdb also shows the number of all lines in the last line of output. If we run wc-l star.pdb, the output only shows the number of lines per file. Okay. The -m and -w options can also be used with the wc command to show only the number of characters or the number of words in the files. Okay, so what happens if the command is supposed to process a file, but we don't give it a file name? For example, what if we type wc-l, but don't type .pdb or anything else after the command? Since it doesn't have any file names, WC assumes that it's supposed to process input given it the command prompt, so it just sits there and waits for us to give it some data interactively. From the outside, though, all we see is it sitting there. The command doesn't appear to do anything. If you make this kind of mistake, you can escape out of this state by holding down the control key and typing the letter C once and letting go of the control key. Control plus C. Okay. Which of these files contains the fewest lines? It's an easy question to answer when there are only 6 files, but what if there were 6,000? Our first step toward a solution is to run the command wc-l star.pdb greater than lengths.txt. The greater than symbol tells the shell to redirect the command's output to a file instead of printing it to the screen. This is why there is no screen output. Everything the WC would have printed has gone into the links.txt file instead. The shell will create the file if it doesn't exist. If the file exists, it will be silently overwritten, which may lead to data loss and thus requires some caution. ls.lengths.txt confirms that the file exists. We can now send the content of links.txt to the screen using cat links.txt. The cat command gives it the name for concatenate, i.e. join together, and it prints the contents of files one after another. There's only one file in this case, so cat just shows us what it contains. So cat links.txt. Okay, output page by page. We'll continue to use cat in this lesson for convenience and consistency, but it has disadvantages that always dumps the whole file onto your screen. More useful in practice is the command less, which you can use with less links. This displays a screenful of the file and then stops. You can go forward one screenful by pressing the spacebar or back one by pressing B. Press Q to quit. Next, we'll use the sort command to sort the contents of the links file, but first we'll use an exercise to learn a little bit about the sort command. The file shell lesson exercise numbers.txt contains the following lines. If we run sort on this file, the output is 10, 19, 2, 22, 6. If we run sort in on the file, we get this instead. Explain why n has this effect. Because n puts it in numerical order. The n option specifies a numerical rather than alphanumerical sort. Cool. We will also use the n option to specify that the sort is numerical instead of alphanumerical. This does not change the file, instead it sends the sorted results to the screen. So we're going to do sort-n links.txt. Alright. We can put the sorted list of lines in another temporary file called sorted links.txt by putting sorted links.txt after the command we just used. Greater than links text to put the output of WC into links.txt. Once we've done that, we can run another command called head to get the first few lines sorted links.txt. So sort in links.txt greater than sorted links.txt. Head sorted links.txt. 9-methane PDB. Using N1 with head tells it that we only want the first line of the file. -N20 would get the first 20, and so on. Since sorted links text contains the links of our files ordered from greatest to least, the output of head must be the file with the fewest lines. It's a very bad idea to try redirecting the output of a command that operates on a file to the same file. For example, sort-n links.txt greater than links.txt. Doing something like this may give you incorrect results and or delete the contents of links.txt. What does this mean? We have seen the use of greater than, but there are similar operator greater, which works slightly differently. We'll learn about the differences between these two operators by printing some strings. We can use the echo command to print strings. So echo command prints text. The echo command prints text. Echo command prints text. Okay. Now test the commands below to reveal the difference between the two operators. Echo hello greater than test file o1.txt. Echo hello greater than test file o2.txt. Try executing each command twice in a row and then examining the output files. Or an exercise data proteins. Hello? Hello. They're both hello. In the first example, greater than the string hello is written to test file 1 text, but the file gets overwritten each time we run the command. We see from the second example that the greater than operator also writes hello to a file, in this case test file o2, but appends a string to the file that already exists, i.e. when we run it for the second time. Appending data. We have already met the head command, which prints line from the start of a file. Tail is similar but prints lines from the end of a file instead. Consider the file shell animals. After these commands, select the entry that corresponds to the file animal subset. So consider the file after the commands. The first 3 lines of animal. Head, 3 animals, tail, 2 animals. The first 3 lines and the last 2 lines, so number 3. Option 3 is correct. For option 1 to be correct, we would only run the head command. For 2 to be correct, we would only run the tail command. For option 4 to be correct, we would have to pipe the output of head into tail by doing head minus n 3 animals.csv, tail into greater than animal subset CSV, passing output to another command. In our example of finding the file with the fewest lines, we are using 2 intermediate file links, text, sorted text, to store output. This is a confusing way to work because even once you understand what WC, sort, and head do, these intermediate files make it hard to follow what's going on. We can make it easier to understand by running sort and head together. So sort dash in lengths.txt head minus n1. The vertical bar between the 2 commands is called a pipe. It tells the shell that we want to use the output of the command on the left as the input to the command on the right. We use the output to the input. This has removed the need for the sorted links.txt file. Combing multiple commands. Nothing prevents us from chaining pipes consecutively. We can, for example, send the output of WC directly to sort and then the resulting output to head. This removes the need for any intermediate files. We'll start by using a pipe to send the output of WC to sort. So WC L star.pdb sort in. Okay, 107 total. We can then send the output through another pipe to head so that the full pipeline becomes WC minus L star.pdb sort head in 1. This is exactly like a mathematician nesting functions like log 3x and saying the log of 3 times x. In our case, the calculation is head of short of line count.pdb. The redirection and pipes used in the last few commands are illustrated below. So output and show, links, output and file, out, in, sort, out, head, output and show. Piping commands together. In our current directory, we want to find the 3 files which have the least number of lines. Which command listed below would work? Which have the least number of lines? Sort in free. I don't think it's this. Option 4 is the solution. The pipe character is used to connect the output from one command to the input of another. Greater than is used to redirect standard output to a file. Try it in the show lesson data exercise protein directory. Tools designed to work together. This idea of linking programs together is why Unix has been so successful. Instead of creating enormous programs that try to do many different things, Unix programmers focus on creating lots of simple tools that each do one job well and that work well with each other. This programming model is called pipes and filters. We've already seen pipes. A filter is a program like WC or sort that transforms a stream of input into a stream of output. Almost all of standard Unix tools can work this way, unless told to do otherwise. They read from standard input, do something with what they've read, and write to standard output. The key is that any program that reads lines of text from standard input and writes lines of text to standard output can be combined with every other program that behaves this way as well. You can and should write your programs this way so that you and other people can put those programs into pipes to multiply their power. A file called animals.csv in the shell lesson data animal counts folder contains the following data: what text passes through each of the pipes and the final redirect in the pipeline below. Note the sort-r commands sorts in reverse order. So, I'm going to say it's going to be the head command extracts the first 5 lines from animals.csv. Then the last 3 lines are extracted from the previous 5 using the tail command. With the sort-r command, those 3 lines are sorted in reverse order, and finally the output is redirected to a file, final.txt. The content of this file can be checked by executing cat final.txt. The file should contain the following lines. For the file animals.csv from the previous exercise, consider the following command. The cut command is used to remove or cut out certain sections of each line in the file, and cut expects the lines to be separated into columns by a tab character. A character used this way is called a delimiter. In the example above, we use the -d option to specify the comma as our delimiter character. We have also used the -f option to specify that we want to extract the second field column. This gives the following output: deer, rabbit, raccoon, rabbit, deer, fox, rabbit, bear. The unique command filters out adjacent matching lines in a file. How could you extend this pipeline using unique and another command to find out what animals the file contains without any duplicates in their names? Cut -d -f to animal sort unique. The file animal.csv contains 8 lines of data formatted as follows. The unique command has a -c option, which gives a count of the number of times the line occurs in its input. Assuming your current directory is shell lesson data exercise animal counts, what command would you use to produce a table that shows the total count of each type of animal in the file? Option 4 is the correct answer. If you have difficulty understanding why, try running the commands or subsections of the pipelines. Make sure you are in the shell lesson data animal counts directory. Nellie's pipeline, checking files. Nellie has run her samples to the assay machines and created 17 files in the North Pacific Gyre directory described earlier. As a quick check, starting from the shell lesson data directory, Nellie types cd North Pacific Gyre. The output is 18 lines and looks like this. Now she types in, one of the files is 60 lines shorter than the others. When she goes back and checks it, she sees that she did an essay at 8 on a Monday morning. Someone was probably using the machine on the weekend and she forgot to reset it. Before rerunning that sample, she checks to see if any files have too much data. Those numbers look good, but what's that Z doing there in the third to last line? All of her samples should be marked A or B by convention. Her lab uses Z to indicate samples with missing information. To find others like it, she does lsz.text. Sure enough, when she checks the log on her laptop, there's no depth recorded for either of those samples. Since it's too late to get the information any other way, she must exclude those 2 files from her analysis. She could delete them using RM, but there are actually some analysis she might want to do later where the depth doesn't matter. So instead, she'll have to be careful later on to select files using the wildcard expression. Suppose you want to delete your processed data files and only keep your raw files in processing script to save storage. The raw files end in .dat and the processed files end in .txt. Which of the following would remove all the processed data files and only the processed data files? This would remove .txt files with 1 character names. This is the correct answer, rm.txt. The shell would expand star to match everything in the current directory, so the command would try to remove all match files in an additional file called txt. The shell would expand to match all files with any extension, so this command would delete all files. We don't want to do that. Key points. WC counts lines, words, and characters in its inputs. Cat displays the content of its inputs. Sort sorts its inputs. Head displays the first 10 lines of its input. Tail displays the last 10 lines of its input. Command greater than file redirects a command's output to a file, overriding any existing content. Command greater than file appends a comment's output to a file. First pipe second is a pipeline. The output of the first command is used as the input to the second. The best way to use the shell is to use pipes to combine simple single-purpose programs. Okay, that was a lot of information, and I am very confused. So I'm going to have to go over that again, probably shortly after this. All right, so we read that part, I think. There's something important that you need to know about programmers. Programmers are lazy, like really lazy. When forced to do something over and over, the odds are good that they'll figure out a way to automate it instead. The good news is that you get to take advantage of the many shortcuts they've created along the way. It's time to learn how to use the command line like a pro, which is to say, in a really lazy way. First, you might have already noticed that copying and pasting inside the command line doesn't work the way you'd expect. When you're inside the command line, you'll need to use Control-Shift-C and Mac Command-C+C to copy and Control-Shift-V to paste. For example, to copy and paste commands from your browser into the command line, you'll highlight the command text and use Control-C as usual, and then paste into your terminal Control-Shift-V. Test it out. Second, you'll need to learn about tab completion. Seriously, this tip will save you so much time and frustration. Let's say you're in the command line and that you need to move into a folder that's far away, something like Documents, Odin Project, Foundations, JavaScript, Calculator. That's a long command to type out, and everything needs to be exactly right in order for it to work. Nope, we're way too lazy for that. Basically, by hitting tab, the command line will automatically complete commands that you start typing. Once there's only one option, for example, it's pretty common to have a Documents folder and a Downloads folder in the home directory. If you've typed cd and then press tab, the command line will let you know that it's not sure which one you want by showing you the different options that match what you've typed so far. But once you've typed in a little bit more, it will complete the name for you, making it possible to write out the full file path above by typing as little as cd. Depending on what other folders exist on your computer, test it out and get comfortable with how this works. You're going to love it. Third, there's a really handy shortcut for opening everything within a project directory. Once you've installed a text editor, you can use this shortcut to open up an entire project and all its files in one go. This shortcut is also commonly used with Git. Later on, it's covered in detail, with commands like git add dot to add all the files inside of a directory into Git's staging area. For example, if you have VS Code installed, you can cd into the project directory and then type code dot with the period. It will launch VS Code and open up the project folder in the sidebar. See the next section of this lesson for a more detailed example. A note on typing passwords. When using a command in the terminal that requires you to enter your password for authentication, such as sudo, the characters should not be visible to you as you type them. While you might think the terminal isn't responding, don't worry. This is a security feature to protect confidential information, like how password fields on websites use asterisks or dots. By not displaying the characters you write, the terminal keeps your password secure. Opening files in VS Code from the command line. You can open VS Code from the command line by typing code, and you can open folders or files by adding the name of the location after it. Okay, and here's some additional resources. The Artline command is a complete beginner's pro maker. It serves as an open source repository. This has lots of pro tips, and I'm sure we're going to be going back to that. Here's an online book, explainshell.com. The cheat sheet, which I did print that out. Command line flashcards so you can learn it, and video series from Learn Linux TV covers 24 videos explaining the basics of the command line. And I suggest you guys go ahead and do that separately. I think it'll be very helpful, but I'm going to go ahead and mark command line basics complete, and I will see you guys on the next one.